So a lot of you guys emailed me personally to answer question D on the quiz review. For those of my students who asked questions on this video will be very helpful for you on your quiz. And for those of you who aren't my students and just wanted to know how to solve the D on the quiz review, this video will be very helpful to you. Alright, so let's start off by looking at our trig identities, and I wrote this up in our last video, so if you didn't watch that, go take a look at it. It's a very good basis for what we're going to be talking about in this video. But we looked at our Pythagorean identities, which is these ones I boxed up right here. We looked at our quotient identities, which are these. And then we looked at our reciprocal identities, which I expect all of you guys to know at this point. We've been working them for quite a while now, but it's right here. Alright, so let's go into question D. So we're going to start off by drawing our table, because this is a proof. The directions do say justify, so that signals to us that it's proof that we will be solving for. And I tell my students always to draw this T-chart. It's very helpful in keeping our work organized. Alright, so let's work with the top of the equation. We see tan squared theta plus 1. So we're going to go over and look at our identities, and we know that if you see a squared and a plus 1, that is probably going to be a Pythagorean identity. So we see that equals secant squared x. So tan squared theta plus 1 is the same as secant squared x according to our Pythagorean identities. And you will see me change theta to an x. I do believe it's a lot easier. I tell my students, so if you're having trouble drawing with theta, just draw an x, and then you can change your answer. I don't know if you guys as teachers will accept that, but I personally as a teacher accept that. So we will then write in this column Pythagorean identity. And now, step 2, we can see that there's another Pythagorean looking identity item on the bottom half of the fraction. Coming over to our Pythagorean identities, we can see that this is probably right here. So if we move the sign over to this side, that's going to be cos squared x, because 1 minus sine squared theta is cos squared x. So drawing that in, secant squared theta over cos squared theta. And this is also with our Pythagorean identities. Now, and you could also, I don't know, again, depending on what your teachers ask for you and what they are expecting grading-wise, you can separate these into 2 different steps or just keep them into 1 step. Again, something you should discuss personally with your teacher. Okay. Now we have 2 squared items over each other, and if we just look at this, we can probably move the cos up by 1, since it is in the denominator. So this is technically the same as secant squared theta is the same as secant squared theta times 1 over cos squared theta slash x. And then we know that this can be moved to the numerator and be changed to secant squared theta. So this would be the same as secant squared theta times secant squared theta according to the reciprocal identity. And lastly, it's pretty obvious what you might do here, but you can just multiply these out. So whether you want to call that the distributive property, whether you just want to call that multiplication, that will turn into secant to the 4th x. And I'll just write multiplication. So that is the step-by-step tutorial solving the question D in the review. If you have any personal questions, leave them in the comments or you can email me.